What is this? That the I corrosion industry and electrolytic refining, Mariam, was very important topic of this chapter, and you missed that because you had an exams of artificial intelligence, and because to score 2 or 3 marks extra in that 1 hour, you can score 2 or 3 marks extra. But you missed 2 and 3 marks in chemistry. If the chapters, if this metal is a non-metal is going to come, then 3 marks question from electrolytic refining is going to come. So in that 1 hour, if you score 3 marks more in artificial intelligence, then you are going to lose your 3 marks in the same chemistry. So what is the benefit? Okay. So if I ask you that what is corrosion? Corrosion is deposition of unwanted layer on the surface of metal when it comes in the contact with the atmospheric gases. When it comes in the contact with the atmospheric gases. यानी कोई भी एलिमेंट अगर उस पर कोई भी एक ऐसी लेयर का डिपॉजिट हो जाना that is not if I'm talking if I'm talking simply that if there is a metal or any metal if it comes in the contact with the atmospheric gases and it and a specialized layer is deposited which give dull appearance to it which is making it dull, so we called it the corrosion. Okay, so note it down. Corrosion, the deposition of unwanted layer on the surface of metals. Done? Noted? Done? And we simply say that rusting, rusting is a specialized name given to the, we can simply say that to the corrosion in iron. क्योंकि iron में corrosion बहुत simple है. Okay, means we can simply say that it is very common. Rusting is the corrosion in iron is very common because it reacts readily very fast, and we can simply say that since the iron corrode, like for example, other metals also get corroded. Like for example, aluminium when comes in the contact with the atmospheric gases, it form a layer of Al2O3. Zn can come in the contact with the atmospheric gas, it forms ZnS or Zn. So they do not actually corrode. They form a protective covering here. But in case of iron, when it comes into contact with the atmospheric gases like Fe2O3.X2, then what happens? This become powder-like structure, and it start corroding the iron. They start corroding the iron. So we simply say that it is corrosion. And the special name given to this is rusting, because corrosion is very famous in iron, and the special name given to the corrosion of iron is rusting. So what is rusting? Rusting is gradual eaten of iron metals when it comes in the contact with the atmospheric gases. We call it corrosion. Oh, sorry, that corrosion is called rusting. So rusting can only happens when we have three things. First of all, iron, because rusting is always take place in iron. Rusting is a special name given for that. So resting Zainab, Ayan, and Mohammad Faizan. Please turn on your camera. Zainab, Ayan, and Faizan. Faizan, please turn on your camera. So when we have this iron, when it comes into contact with the atmospheric gases like oxygen and water, so these two things are also required. If any one of them is missing, the rusting will be prevented. Rusting, there will be no rusting. Okay, if iron is not there, so copper we cannot say that rusting is taking place in copper. Rusting always take place in iron. And if there is only water but not oxygen, then no rusting will take place. If there is only oxygen, no water, so no rusting will take place. So any one of them is missing, rusting will not take place. So rusting is done when Fe react with oxygen to form Fe2O3 dot XH2. That is called rusting. Okay. In order to balance it, there are three oxygen and there are two oxygen. So you have to multiply by 3. Now it becomes 6. Now you have to multiply by 2 to become 6. Now it becomes 4. 4. And here, this is the water of class. This is X. So X is water of crystalline. So if there are two water of crystalline, 2X is 2. You will write here 2. So this is the equation for rusting of iron, and this is the formula for rust. Fe2O3 dot XH2O is the formula for rust. Formula for rust. Okay. So rusting take place only when these conditions are satisfied. If you have only water, no rusting will take place. Only oxygen, no rusting take place. Oxygen and water both are required to do the rusting. So whatever written on this page, please note it down. Note it down. Done? Noted? Yes or no? Zainab, noted? Faizan,
Yes,
are you there?
yes, sir.
Mohammad Faizan, are you there?
Yes.
So please turn on your camera.
My camera is on.
Okay.
I'm asking for the Faizan. Next. Yes, noted everyone. Alvina, noted each and everything.
Yes.
So if I ask you one thing here that several times it happens that like in case of aluminium when comes in the contact with the atmospheric gases, okay, so it forms a protective layer over it, and that is called Al2O3, which is not like powdery. Like in iron, it become powder like, and it start coming in the powder form, and day by day, the metal rod, iron rod or iron grill, what is the substance or which is structure it is made up of iron, it start corroding and it start coming in the powder form. But in case of aluminium, it forms a protective layer. It does not let to come in the powder form. It is not powdery. It is strong. So why we are calling it corrosion? It is good. It is protecting. Then why we are calling it uh, corrosion? Because Al2O3 gives dull appearance and it is unwanted. We don't want it, but still it is reacting. It is forming. So we don't want aluminium to make aluminium oxide, but it is automatically forming. And moreover, it is giving dull appearance, not shiny. So that's why we called it Al2O3. After the protective layer in aluminium, so this is the corrosion in aluminium. So Al2O3 and rusting deflation. Similarly, if I'm talking about the copper, so copper, when comes in the contact with the atmospheric gases, it forms copper carbonate dot copper hydroxide. Can be either copper carbonate alone. If it forms copper carbonate, then it can be also correct. अगर दोनों आता है तब भी सही है, अगर एक आता है तब भी सही है. अगर कॉपर कार्बोनेट आया या कॉपर हाइड्रोक्साइड आया तब भी वो रस्टिंग कॉरोजन माना जाएगा कॉपर. एंड दिस लेयर इज ग्रीनिश कलर. कैसा होता है कलर? दिस इज ग्रीनिश कलर. ग्रीनिश कलर. Okay. So if I'm talking here that copper carbonate dot copper hydroxide is greenish color, and since it is a basic layer, it is a basic layer. Basic layer. So when we have mild acid, जब हमारे पास mild acid हो, like नींबू lemon juice, or if we have citric acid, mild acid or vinegar. So if we washed or we rub it with that, we take lemon juice and we scrub, okay, this copper utensil. Or let me show you that how does it becomes uh, in the corrosion in copper. So how does this corrosion in copper take place? Let me show you. So you can check this one. So when copper comes in the contact with the atmospheric gases, it becomes greenish color, greenish. And when we rub it with some mild acid like citric acid, okay, then it becomes. So this is like you can see here.
Sir, we can see your
Yes,
slide.
you can see here.
Uh,
This is green. So this is a greenish coating that is coming over the copper. And this is not copper carbonate or copper hydroxide. This is brownish black in color. Okay. But when you comes in the contact with these gases, so it becomes copper. Okay, copper sulfide. So when you rub it, it will change its color. And this copper carbonate and copper hydroxide, both layers are there. Copper carbonate and copper hydroxide. So carbon dioxide and water, when it comes into contact, it forms copper carbonate and water, which is blue in color. Okay. So first, it forms copper oxide when it comes from copper carbonate or copper hydroxide. So this is the region of the corrosion coppers, which is black. And this can be like Statue of Liberty. The photo A showing the Statue of Liberty covered with copper skin. This is the copper skin, and which was originally brown. Exposure to the element has resulted the formation it to blue green color. Now it has become blue in green color as seen today. So actually it was having a copper coating, but initially it was like this, but now it is like this. Okay, so color of the Statue of Liberty is changing. Okay, it's because of corona. अगर हमारे फेस पे मुंह पर अगर कोरोजन हुआ करता तो क्या होता? होता तो है टाइम के साथ. Okay, so what we are doing here is that so copper carbonate and copper hydroxide can be removed. This layer deposited on the surface of the copper when it come with contact with atmospheric gases, and this layer can be removed by rubbing it with this layer can be removed. This copper carbonate copper hydroxide layer can be removed by using mild acid. Because mild acid or when we remove it with mild, because this layer is of base calcium copper carbonate and copper hydroxide, the both are base. So they can easily react with acid and dissolve, and the new layer will come. So the fresh new layer will come. Okay, new layer. So this can be. So please note it down from here. Fast. Done everyone?
No,
Noted?
no, 1 minute.
Ayan, are you writing?
Sir, finished.
Vedant, why are
Yes,
you hiding? Why are you hiding yourself?
sir, I'm using PC. I don't have a webcam.
Done.
So the question came in examination. This question. A brown color substance X, when it comes to the contact with the atmospheric gases, it forms another compound Y. The compound, when rubbed with mild acid like citric acid, lemon, it is its substance get brown in color. Find the X and Y. Find the X and Y. So what is brown color X substance? Tell me first.
Copper.
Copper.
And what is Y? What is Y?
Copper hydroxide.
Y is copper carbonate dot copper hydroxide. Okay. Y is copper carbonate dot copper hydroxide. Got it?
So we can
Yes.
write copper hydroxide first and copper.
Yeah, it's your choice. You can write any one of them first. But the same question comes. A brown color substance X, when heated, it is brown in color. Brown. When heated in the presence of oxygen or air, then it gives a black color substance Y. Okay. So can you tell me that how can we do this one? What is that X and Y? So when it is saying always brown, so it is copper. And when heated to gives you that it will be copper oxide, Cu2O. It is black in color. So Cu2O is black in color. Okay. And CuCO3, CO3 dot CuOH whole twice. Then
Agree.
it is green in color. It is green in color. The color is important. Okay. Now this has black color. This is not corrosion. This is not corrosion. We are heating it. Okay. This is not corrosion. Now silver, when comes in the contact with the atmospheric gases like sulfur, and form Ag2S. Ag2S, which is black in color. Now you know that silver also exists in nature in the form of silver sulfide. It is an ore of silver. So how we get pure silver from this? We can get pure silver by Cu2S. When you heat it in the presence of oxygen, it will give you Cu. Roasting we are doing. It will give you Ag plus sulfur, Ag2O plus sulfur dioxide. And when you keep on heating, it will give you Ag2O. When you keep on heating this one, that will gives you, this is heating, that will gives you Ag plus O2. Got it? Yes or no?
Yes, sir.
Yes.
Please do it, please. Let me do it from here. Here. That Ag2S is black in color. It is black in color. It is corrosion. Done.
Done.
Sir, 1 minute. Another.
Do it fast. Should I move forward?
Yes, sir.
And the next one is rancidity and rancidity. What is rancidity? Yes, you can write ion, but the chapter should be same. If we are discussing metals or non-metals, what should be? So if I'm
Okay,
talking,
sir.
what is rancidity? Rancidity means like oil containing fats, oil containing substances. Okay. Like food, oil containing products like food, any other substance. Okay. Generally, when they comes into contact with the atmospheric gases or fat containing, only fat containing. Okay. So they start producing foul smell, unpleasant smell. Okay. We call it rancidity. That result in the change in taste and smell of food. Okay. So when our food or oil containing or food containing oil containing food when comes into contact with the atmospheric gases O2, it result in the in foul smell, in foul, unpleasant smell, and change in taste of food. This is called rancidity. And how rancidity can be prevented? Rancidity can be prevented by adding oil, by adding salt, by adding sugar, by keeping it in a refrigerator, by keeping it in airtight container. So if you do it in any one of them, okay. And moreover, if you are talking here that there are some chemical preservatives also like BHA, butylated hydroxytoluene, butylated hydroxy, anisole, and sodium benzoate. So these are the chemical preservatives. Like in pickles, you see that we kept oil over it in order to prevent the pickles to come in the contact with the atmospheric gases or moisture. We add more oil over the surface of pickles so that the oil layers act as a barrier, as it act as a barrier. It will not let the oxygen to come in the contact with the main pickles. Okay. So start writing it fast. Rancidity. Done, noted.
Yes.
Okay. Next is that why do we fill chips? Why do we fill nitrogen gas in the chips packet to prevent it from rancidity? Just the reason behind this, nitrogen behave is not an inert gas, but it behave like an inert, and it is majorly present in 78% in the nature. Other noble gases that do not react with it with anything, they are like helium, argon. They are in 1%. They are less than 1% in nature. And nitrogen is not an inert gas, but it behave in inert gas. Why? Because nitrogen has 2,5 electronic configuration. It has 5 electron in its outermost shell. So in order to complete its octet, it share with three electrons each. Ayan, look at the screen. What are you doing? So they share three electrons each, and when they shares, it will become triple bond. So when you break one bond, then it's still two bonds are there. Now you have to break these two bonds, then it's still one nitrogen atoms is there. So you require large amount of energy to break the nitrogen two atoms separate and then to make new bond. So here, like for example, if you have nitrogen reacting with hydrogen or nitrogen gas reacting with oxygen, it require high temperature and pressure. High temperature and pressure. High temperature and pressure. Okay. So to gives ammonia and to gives NO2. That's why 2NO. This is why these two are endothermic reaction. Endothermic require large amount of energy to proceed. While if you have a, like instead of nitrogen, if you have hydrogen and oxygen, it will gives you water, and this time large amount of heat is being released. Similarly, if you replace this oxygen with if nitrogen with hydrogen, you will get H2O, which is large amount of heat is being released. So in case of nitrogen, this is because of the triple bond, nitrogen behave like an inert, does not react. It react at very high temperature. So that's why I filled it in the chips packet, because it is easily available in the atmosphere in more percentage, easily to get. Note it down, nitrogen behave like an unreactive gas because of its triple bond between the nitrogen atoms. Moreover, it is present 78% in the atmosphere. Note it down fast. Done?
Yes.
So let's move further towards the alloys. So now you understood what is corrosion, what is rusting, and what are the things required to for the to prevent rusting. Okay, we sometimes do oiling, we do sometimes greasing, sometimes we do galvanizing. Okay. Now moving to the next part here is, let's move towards the alloys. Alloys are the homogeneous mixtures of two or more metals and non-metals. We do that one. So what are alloys? Alloys are the mixture of two or more metals, like it can be zinc or tin. It can be copper and tin. It can be lead and tin. So where we have metal, and sometimes we have metals and non-metals. Like in steel, we have carbon, which is a non-metal, and iron, which is a metal. So these are called alloys. And why we are making alloys? We should know the purpose of why we are making alloys. Why there is a need to make alloys. Like for example, these are the iron atoms, which are present in the strip of iron. Okay. And when we place heavy load over these iron atoms, what is going to happen is that these layer can slide and can form like this, can deform. Even it can deform like this. It can come into the here like this. So this sliding of layer from here to here, okay, this on the basis of atomic level, this is a great slide. Okay, means it can distort, it can change the shape. And if like in case of railway tracks, if we are talking heavy on which a heavy load is running at high speed, so we require strong iron so that it will not distort, its shape will not distort. So what we does here is that we fill, because iron is big element, it has bigger mass and size. Its atomic number is iron atomic number is 26, so it has large number of shells. So because of that, it has bigger size. Carbon has only two shells, 2,4, atomic number 6. So when we fill carbon atom, when we mix carbon atom with it, it comes into its space here like this. Carbon. It is coming here. Okay, and then it prevent it from sliding. It come into its voids. So it cannot slide further. It cannot go into this space. So it prevent it from missing. So this is the structure of steel. We did steel. Steels are made like this in order to increase the tensile strength. Secondly, for example, I have a requirement of for soldering. I need a metal which should be a good conductor, but it should be used for soldering purpose. Let me show you what is soldering. Solder is an alloy of copper and tin, sorry, lead and tin, which is used to sold. Okay, like you can check it here.
The videos are lagging.
So this is a soldering iron. Okay, this is soldering iron that is made up of lead and tin, and it can easily melt. It has low melting point. Like the iron, it does not. Like iron has very high melting point. So if we wanted to do the solder, okay, on some electrical wires or on the electrical boards. So what we does here is that we solder it first with this metal, and then easily it can be soldered on the board. It can be easily soldered on the board. Here you can check that. Here you can check it. So it is being soldered, okay, with that metal. Okay, now applying the paste so that it will stick, and then this metal is easily melted and can fix this wire over this board. Okay, so this is the soldering. Now this it get pasted here. Okay, so it can be easily removed, it can be easily attached. Okay, so this is possible when we are doing this soldering. Okay, the soldering is easy, okay, with the solder with an alloy. If we take other metals like iron, so it will require very high temperature, and it will melt it even the board also. So we can simply say here that we use a metal which okay, which is used, or which has low melting point. And how can we find this one? We can find this one, for example, if we have this like we find that there is a metal A which has A types of atoms inside it. Okay, A kinds of atom, and there is another metal B which has B kinds of atoms. Now we come to know their properties that A and B particles do not like each other. They hate each other. They don't like each other. A particle love each other, B particle will love each other, but A and B particle hate each other. What we does? We mix them. We mix them. We mix them. We add these two. We will A and then B, then A and then B, then A and then B. So they have a repulsion force. They don't like each other. They want to go. They want to separate. The force of attraction, as a result of which the force of attraction between these particles will decreases, and they can easily melt. They can easily move freely at low temperature. Similarly, for making the aeroplane, we require a metal which is low in weight, as well as very good high, or we can say it should be very strong. It cannot be easily means it should be highly durable. So we have magnesium metal and aluminum metal. Magnesium has magnesium. Okay, so magnesium and aluminum. We find to know that magnesium metals, the force of attraction between the magnesium atom and aluminum atom, they like each other. And but they aluminum and magnesium metals, when they mix together, they have a great force of attraction between them. Okay, then magnesium atom, then aluminum atoms. So they have more force of attraction. So when we attract them, when we mix them, aluminum, magnesium, they form magnesium, and they have very high force of attraction than magnesium atom and aluminum atom. So this alloy is going to be stronger than magnesium and aluminum atom, because they have huge force of attraction. Okay, and it can be a large force. The same thing happens here also. So alloys are the homogeneous mixtures which are purposely made according to our need. Whether we need sometime metals, low reactive metals, low melting point metals, sometimes we require high melting point metals, sometimes we require good melting point metal, sometimes we need thin wire with high resistance, sometimes we require thick wire with low resistance. So this is different types of metals that depending on our need these are called alloys, and these are made. Moreover, when steel and stainless steel, if any alloy contain iron as an one constituent, यानी किसी भी alloys के अंदर अगर iron है, तो that is considered to be as ferrous alloys. और अगर किसी भी constituent के अंदर, किसी भी alloys के अंदर mercury as one of the constituent है, तो उसको हम amalgam बोलते हैं. What we called it? Amalgam. Got it? Note it down fast.
The alloy in which one of the what's written after that?
Constituent is mercury is called amalgam, and which in which one of the constituent is iron, it is ferrous alloys.
No, I mean like for amalgam, it's written the alloy in which one of the what's
Constituent is mercury.
okay.